Hello there, welcome to another problem, a very famous problem, just like the twin paradox that we did yesterday. So this is a problem, goes by many names. It has to do with a ladder through a barn paradox. It's sometimes called ladder through a barn paradox. Okay, so what it is you have a barn. So this is barn, and here is the ladder. So it has two doors, the door 1 and then you have a door 2. So this is the front, this is the back door, and then you might say, well, there is more to the barn, like that, and things like that. You can have a structure, three-dimensional structure, but this is cross section. So someone, maybe a person, is running with a ladder, what have you, or the ladder is just cruising at speed v. So just imagine this happening. Forget gravity and all those complications. So this has speed v. So the ladder has this length, which is larger than this. But if it's just going with some speed v, then as the barn is concerned, the ladder's length will be reduced. So if you have a length contraction formula, so if it's L0, it's moving at v. So in terms of barn, so barn when C, the length of the ladder, L, will be 1 over gamma times L0. And the gamma is the same, 1 over square root of 1 minus v square over c squared. Okay? And this is, because this is greater than 1, L is smaller than L1. And depending on v, L can become less than omega, less than W. W is this W is W0. So the width of the barn when the barn is at rest. Barn is not moving anywhere, barn is just at rest. So when the ladder comes in, there will be a time when the ladder is completely inside. So at this time, both front and back doors are slammed shut, and at the same time, for an instant, this is between here to here is delta t is almost 0. Okay, you bring it down and then bring it up. It's just a way to set up the problem. Okay, and the ladder is still going, and you might say ladder is all the way in, what have you. Ladder can be half the W0, so it's right in the middle somewhere. Okay, and it just happily goes through the barn. Okay, no problem. In another version of this problem is the second door. This door remains shut. Okay, once shut, the second door remains shut. Or you can have both doors shut. All right, so you just shut it, that's it. So the another variation is, so when you shut it, so the doors are shut, and this ladder is going, so it's going to go slam into and say this is shut through a very hard material, and it's going to get completely destroyed here. That's it. So this will keep going till ladder is just pieces. Okay, so this is and you can see the left door is shut at the same time as the right door is shut in this frame. Nothing unusual, right? This is just nice. It can be done. However, the problem comes when you look in the ladder frame from the perspective of ladder. someone taking the ladder. So this is at rest, and the barn is coming at it. And over here, W is W0 over gamma. And gamma can be large, so that no matter what you had, the width of the barn, it can be made to be smaller than the width of the ladder, right? The length of the ladder. So now it's coming at it. It's smaller than the ladder, and you can see that if I shut both the doors, this ladder is not going to fit in there. And so this maybe chops the ladder into like one piece, another piece, you know. This is a completely different outcome than over here. The ladder just goes through. So we just don't do this path yet, okay? Just slam the door, open the door like almost an instantly, and then ladder goes through. And here the ladder doesn't go through. So there must be a problem, because there can be only one solution. There's no acceleration or anything here, right? So unlike the twin paradox, what we have completely legitimate inertial frames. This frame is inertial. This is at rest. This is at rest. This is inertial frame. So it's completely between two inertial frames. So there must be some catch here why this thing not working out. Okay, there will be some catch. Okay, let's do this problem. I've been gone for a while. Okay, let's see. So as I know, so far I recorded just the problem, and now here is the solution, right? So if I look at the barn, picture so we're gonna have a situation like this, okay? So we have stick is moving. So original length of the stick was some original length for L0, but moving with a V. And from the perspective of the barn, so this one is at rest and this is moving. So if this L0, so this is W0, so this L0 will become L0 over gamma corresponding to that is relative speed V. Okay. Now we expect this to be inside here and it will fit. So the situation I'm looking at is, this is the time I'm looking at this instance where I will just say it just fits. I will even say that this so this is the instant I'm looking at. So this guy is still moving and it just fits. Okay, so the front of this is going to close and then open. So down and up. And back of this will close and up. So there are actually two events happening. And in the frame of this barn, this event 1 and event 2, they happen at the same time. So we can write down things like this. We can say, but this will appear differently when we look from the ladder's perspective. So from the barn perspective, the event 1 from the barn's perspective is equal to event 2. I'm just going to denote like this in the barn's perspective. And to make it simpler, let's let's this be let's this be the x-axis and time axis, and when the for the ladder, let's assume that these are the same point. So this is O for ladder, and it's the same O for barn. And so we're saying that we're going to pick a time so that the two frames where the front of the back of the barn and the front of the ladder, back of barn and front of ladder. This is the front of the ladder. When they're right on top of each other, or so you can say that this is just a little bit before and a little bit after. So you might say this is 1 prime. So 1 prime is just a little bit before, then you have a 1. And over here, you can say the ladder is, let's call it 2 prime for the ladder. And then you have a, first you have a 2 prime, go in, and so this is 2 prime and then 2, okay? So but these two are the same time, but these two we'll find out are not at the same time, okay? Although we can assume they're right on top of each other for the sake of simplifying. Okay, so for us this is equal to 0. We're just setting up so that everything is 0. And what about the x's? So the x of this 1 is 0. X of but x of 1, I'm not going to write like that, right? This is equal to 0. Just looking at the 1 first, and t in the this is the frame will be ladder frame XL and TL. So t in of this event in the ladder frame also 0. So this choose, we choose that, and so this is also 0. So this is also choice. So basically we're choosing the frame to on top of each other just for calculation purposes, okay? There's no magic here, it's just choice, what I'm going to call 0. Okay, now let's look at this from the description of the problem, time of this event in the barn frame is the same as on the other side. So time of the 1 in the barn frame, and this one we already chose to be 0, so it's going to be 0. So this is by setup. That's what we say, that we're going to close the door at the instant at the same time on both sides in the barn frame. Okay, good, you understand that, right? So how about x of this incident in the barn frame? In the barn frame is if x equals 0 here, and this is the width of the barn, so it's going to be minus W0. And we said W0 is equal to L0, so W0 is L0 over gamma. Gamma can be bigger than that, but I'm going to choose 1 gamma such that it just fits. This thing is same as that, okay? So there will be minus L0 over gamma. This I'm choosing. I'm choosing a V so that it just fits in the barn rest frame. Okay, this I'm choosing as convenience. If gamma is bigger than that, it will still fit. But I'm just going to choose that. So these are I can do in the barn frame. Now let's look at what happens in the how does this whole thing looks in the ladder frame. So the ladder frame, the barn, so here's the ladder frame. So this is at rest, this is with L0, and so this is moving. Then this width will be now W0 over gamma. The width of the barn will shrink, right? So it won't look like that wide anymore. Over there is going to look like that. So that's going to be W0 over gamma. So let's draw some pictures over here. I'm going to draw some picture here. So this first thing will look like so that's going to be that's when the first in and out, that's the first incident or first event where the close the door, open the door will look like. So the ladder is way out here when it's all, so it's not fitting in actually. So this is already all of this, and in this frame the barn is moving and the ladder is fixed. Okay. All right, so now I have and so in terms of coordinates in the ladder frame, it looks like this. So this is the X ladder, T ladder frame. So ladder is fixed, is stationary. This coordinate is minus W0 over gamma, right? And this coordinate is minus L0. Okay. So this event 1, so no problem. What about event 2? Event 2 is when this thing has reached over here. So event 2 looks like this. Event 2, at that instance, this kind of supposed to go like this. So the ladder will go through, right? So here is a for the event 2. So this is the event 2, and let's see if it's consistent with this. Okay. So if I do Lorentz transformation for this, so what is the time of the event 2 in ladder? So what's the time here? Time of the 2 of the ladder. What is the time? We know x2 in the ladder is minus L0. This we know, but we don't know time ladder. Well, we can get from these and the relative. So this guy is moving to the left. So it will be gamma is same speed as the other ladders moving. Relative is the same gamma. T2 in the barn frame, so let's use this guy, and then we use this guy plus you can see V over C square. So V over C square. So the V is negative, so it's going to be minus negative V over C square, and times this distance times x2b. So we use x2b with minus W 0. So but this is 0. So and this just becomes is instead of at 0 time, ladder will see this positive time later, right? So W0 we can write L0 over gamma. So L0 over gamma. So multiply by gamma, we get V L0 over C square. So it's going to be that much time later as was so this closes and opens, and then the front of the barn comes and opens and closes this much time later. Well, so that we should be able to say that it should be consistent, right? It should be consistent, that you can see that the back end, or this, not back end, but this end of the barn has moved this much between the time here and now. So let's see. So let's call it A to B. So the front end of barn moved. So we're looking at ladder frame, right? We're looking at that. Moved how much? It moved L0 minus W0 over gamma, and W0 equals L0 over gamma. So this is L0 minus L0 over gamma square. So this is the delta X, and amount of time it took is this amount of time. So delta T was VL0 over C square. Now if I find delta X over delta T, should be V, right? So let's check that out. I'm going to erase some of this and try to get some space. So to be consistent, we should check this out. That so to check if delta X over delta T in the ladder frame of front door of barn is actually that relative speed V. Okay, so let's just quick calculation. It's not that hard to do. So delta X over delta T. So delta X is this. Let's summarize this. L0 1 minus 1 over gamma square. So L0 1 minus V square over C square, because it is reverse, so it gets like that. 1 cancels out, and so it's L0 V square over C square. Delta T is from the Lorentz transformation. We know over here T was 0 when the barn front edge was here is T equal to 0. We already know that this was the T equal to 0 situation. T in ladder was 0, and T in ladder over here is this quantity. So this delta T is that. So so V L0 over C square, and you can see L0 cancels out, C square cancels out, one of the V cancels out. So yes, V. So and that's how it is consistent. The story is different. That's what it is. Okay. Physical phenomena is same. The ladder actually fits. Ladder, in the barn it fits, but the main thing is the ladder actually is able to make it through the barn. Okay. Even when the ladder is longer than the barn, the confusion is like, okay, if it fits, what happens to the fitting? As far as the ladder is concerned, it never sees it sees the back end of the barn at an earlier time and the front end of the barn at a later time. So at no time it's actually in the front and between the front and back, and that's what the confusion is. So this, like, what happens simultaneously over here. Let me use a different ink. So what happened over here and here, the two front and back were simultaneous in the barn frame, but they're not simultaneous in the ladder frame. So this is a test of simultaneous events in barn are not simultaneous at two different locations. Not simultaneous in not simultaneous in the ladder frame. So there you go. This is a interesting paradox and confuses a lot of people. And when you, it's kind of hard to state it and stay on the message. But if you're confused, okay, it's really natural to get confused about this, because things, we are kind of in everyday life where we're very used to simultaneous. What's simultaneous for one is simultaneous for all, but that's not the case actually. At the speed, relative speed of the observers gets higher and higher, and if you get close to the speed of light, you can actually see the difference in practice. Okay, so I'm going to stop here. Take care. Bye.